Hi Leo, how are you today?
Hello, I'm doing fine.
So Leo, before we start, please tell me, Leo, what is the most important topics that you would like to have exercise on starting from the next class?
Oh, well, would it be possible to go over some well, like outside of programming, just like computer science IB, like paper one?
Okay, so you have to also rank for me the topics in priority to start with. So I will allow you some time. Can you write that to me after the class?
Yes, yes,
Okay. Because I mean, the reason for that is that we don't have too long time.
yes.
So we have to check the most important things in your opinion, or the most difficult topics in your opinion first, and we tackle them one by one. Okay.
Yep.
Okay. So Leo, did you have a chance to make this contact class?
So I typed in what was on the slide, but I haven't like finished making the like object yet.
Okay. But before that, let me. So I will give you the share, but not now. Just let me finish a few topics, um, a few exam-like questions for Qs. So let me go through this now, and I will give you the share later. So,
Yep.
uh, so typically, even in paper two, sometimes he asks you about the linear queue. So he will ask you differentiate between linear queue and circular queue, explain one advantage and one disadvantage of each. So what do you think we can answer this?
Well, advantage and disadvantage of each. Well, an advantage of a linear queue, uh, given that we're talking about actually, okay, so. Yeah, for a circular queue, the benefit would, okay, a benefit of a linear queue over a circular queue would be that, assuming that we're talking about like dynamic linear queues, then the size can be unlimited.
Mm-hmm. This is for the linear
Yeah,
or circular.
because
Okay.
because the disadvantage of the circular queue is that you have to dequeue some objects if you want to add more.
Mm, okay. So, okay. And what is the difference actually between linear queue and circular queue?
It would mainly be the structure where for a linear queue, as you enqueue and dequeue, the how do you say it? Like the number, I guess, is like keeps going up. Meanwhile, for a circular queue, it's
Mhm.
there's like a given number, but it like
Okay. So, and there is no problem I mean, again, as you already know and experience, I'm asking so that you try to recall the information, and I know if the information is really or well organized in your brain or not yet. So, okay. One advantage here, if we want to talk about linear um, and circular, here, okay, so linear elements are added at one end and included and removed from the other end. We already know, so if we're talking about the difference between the linear queue and the circular queue elements are added to the rear and removed from the front using a circular approach within a fixed size array. But again, they are different in a way that linear queue, if you have a queue in this way, and your front is here, and your rear pointer is here. So if you reach it here, it means that you really need to wait until the whole queue is totally empty until you are able to utilize the queue again. So if you have items here from 1 until 10, and you already fill in to the maximum size of the fixed size queue, so this is a linear queue. You are not able to fill in the queue again unless you totally remove the last element inside the queue, because this is not a recycled queue. So the circular queue in the other way around. So I am not doing it perfect, but okay, I'll try. Okay, so that's not totally perfect. So I would say 0, 1, 2, 3. So we have 4 elements in the circular queue. So it means that if the front is here and the rear is here, it's true we are not able to utilize the queue anymore. But once the front pointer here is moved up front using a dequeue, so this will become empty, and it means that our rear pointer can start adding more items here, so it can move here. But this cannot happen in the linear queue. So it means that linear queue, once it is filled, and even though you start to dequeue from the queue and you move the front pointer like that, there is no way that you can fill in the queue again. It will still look towards the end of the queue to see if it is full or not. So it is marked by being full by checking the rear pointer. Okay, so that's the difference between the big difference between both of them. And this advantage of a circular queue is that the implementation is quite complicated. It's complex implementation to be able, you have seen, I think, we have to use the mode when we are enqueuing and dequeuing. The code is not straightforward. It's a bit tricky, right? And even when we are starting the front queue and the rear queue, they are also, their condition is slightly different from here, which one where the linear queue start with front pointer with 0 and maybe the rear pointer with -1. So they are slightly different from each other, and the linear queue definitely is much more easier. Do you agree with that?
Yeah, I do.
So also one disadvantage here from the linear queue is that it is a limited size. It means that once we are full, we reach the end of the queue, we are not able to add any more unless it's become totally empty. So this is one of the disadvantages. Again, I think you know the information, but maybe it needs to be slightly more organized. Okay. Do you have any questions in what I said to you?
No.
Okay. So, okay. If a linear queue is implemented using an array, what happens when you try to enqueue an element into a full array? Briefly explain 2 solutions to handle this situation. So what happens if you try to enqueue in a full queue
for a linear one?
Okay, it gives you an error or a message that you are that you reached the array is full, right? You have to say the queue is full, right? Okay, so describe a real world scenario where a linear queue would be suitable data structure and explain why. So a lot of these real world scenario questions. So give me an example of a linear queue in real world scenario.
Maybe like a pet counter.
Yes, so if you go to a grocery store and you queue in front of the cashier, so definitely you will have to make use of a linear queue, right?
Yeah.
Okay, so describe a real-world scenario where a circular queue would be more suitable data structure than the linear one, and explain why. I understand it's a bit tricky. I understand that. It's okay. It's fine. So the point here that one of the examples that we should be able to see if you know that there is a queue actually for the processes inside inside the operating system, and they use that to, how to say, so if we if the process is waiting for a CPU time, so it wait its turn to be able to be served by the CPU. So we have a limited amount of processes depending on the available resources typically for the system. So we are actually here utilizing a circular queue because once a process goes out to be served by the CPU, its place is empty and another process can be inserted there in the circular queue to take place. So we don't have to wait for the whole. So if we use a linear queue, we have to wait for the whole queue to be empty to be able to insert more processes. And this doesn't make really any sense because computer always need to be responsive, and to make it responsive, it have to be fast, and items need to be quickly inserted in a queue where CPU can really serve them once he have a chance. So he will start with the first process, the most important process, and then he will keep dequeuing out of the circular queue. Once something is dequeued out, it gives space for another processes to be inserted in the queue. Does this make sense to you?
Yes.
If it doesn't make sense, there is another example also that can be used. If you imagine, did you deal with printers before?
Printers?
Yes. Did you print any
Yeah.
item on a printer before?
Yes. Yeah.
Okay. So in printers, we have something called printer spooler. So this printer spooler is like a queue, but a circular queue in this case. So anybody is able to send any document to the printer spooler. So even the printer is still printing something, you're still able to send a document to the printer spooler. So it will queue it out for you, and it will wait until it takes its turn, and then the latest document will be printed. So it means that always the printer spooler is able to receive items, and it doesn't wait until all the queue, the spooler queue is empty to take new items. So it will keep taking. So by time when there is a papers coming out, you still sending more papers, it will still insert it in the queue and it will accept it. Okay, and then once it finish everything that comes first in, so it will print your latest document out. Does this make sense to you?
Yes.
It makes. So which explanation was more easier, the printer spooler or the queue for the processes that take advantage of time from the CPU?
The CPU.
CPU. Okay, good. So I will also tell you something here. They will ask you for implementation for linear queue. We have done something like that in the previous classes. We have implemented actually a static queue a static linear queue, and also we have implemented a circular queue. So what I wanted to say is that although we have done this in a procedure way, we didn't implement them through a class, but this can easily be changed to be utilized through a class. So if you look here, although he doesn't request this, but just in case, it's just a simple thing here. So you are defining a queue here. This is a linear queue class. So you create a class that is called linear queue. You create a queue inside in this way, and this is an integer for front and rear pointers, and then the size is decided by your constructor. Okay, so you initialize a queue with a new size, whatever it is, and then you implement the enqueue and dequeue and isEmpty and isFull exactly the same way that you have done with our previous implementation. There is nothing more changed. The only different thing is that this is how it should look like if you put it in a class. But other than that, it is just simple. And this is also not so far from what we have done. It's actually close, except the constructor part when you give the size there. So does this make sense so far?
Yes.
It's easy or difficult?
Oh yeah, that is fine so far. Yeah.
Okay. Are you able to take as a homework? I will give, because I will give you long homework because we have a long time, right? We have a.
Yeah.
Okay. So your homework is to actually to do something similar to this for the circular queue. It shouldn't be so much difficult. It's almost the same if you look at the concept here. The enqueue, dequeue, isEmpty, and isFull exactly the same methods. You just need to only implement them inside the class. The tricky part or the slightly different part would be just only here. Okay? Can you try to do that for the circular queue as a homework?
Yes.
Okay, good. So now let me see. Did you manage to implement the contact class itself? But you
No.
didn't manage to write those, right?
So I wrote them, but like I haven't like completely finished the contact class.
Okay. So let me see. Let us go through it then together. Can you share with me? So what else did we have as a homework other than that? Did you manage to do it?
Just finishing the reverse queue.
Did you already manage to? But we
Yes.
did the reverse queue except the portion where we tried to print out, right?
Yeah, and I finished that as well.
Okay, so can you share that with me, please?
Okay.
Did you test it if it works or not?
Oh yeah, I did.
Okay, that's good. That's good. How good you are in the sorting algorithms and the binary search?
Yeah, I think I'm quite familiar with it.
Are you able to write code for those?
Yes.
Okay. Did you manage to finish all the computer science paper 1 syllabus?
Paper one, yeah, I've gone through the whole syllabus.
Okay. And what, yeah, so like we agreed that you tell me what was the most difficult topic so we can go through it. Okay, this is the contact.
It's just this is the reverse and the output. Oh, just a second.
Okay, output queue. Let me see the output queue. So one thing to organize your code is actually to okay, yeah, okay. So this is output. Show me your code for the output, please. Output, the queue size. Yes. So actually, one trick actually not to use that line. Just use while and while not queue is empty. So this can actually do a good job without using this thing. But what you do is not wrong. It's actually correct. Just a more simpler way. Okay, add. Okay.
I feel.
Let me see. Let me see. You use I. But actually, well, if you use remove and you put it, let me see actually. So actually, you can put that here like that. You already. Okay. So let me see. So actually, what you do is you can put this remove directly here instead of that line. So this line on number 60, yes, and then remove it from number 60, yes. And here, put this. Okay. Yep. Okay. Try then. Null car. So that is what? This is slightly different. So I would say print statement. I would like to see, just put print here and put also print somewhere here so that we know if we're actually doing something correctly here or not. And please, this one cannot be 0 inside here. It have to be initialized up here with 0. Yes, and remove that line. Yes.
Print queue size or
no, I would just like I would like to know that okay, I would like to mark that this is the start of the output queue, just a normal text. Yeah.
at the end of it.
Here just to mark that we are adding correctly. So I would like to print that items, but put a text beside it. So put this inside the double quotation and also outside it. Yes. Okay. Yes. And then outside it, yes, put the real one. Okay, good. So basically he will give you also an error here. So I would say he doesn't like it. You just remove this. Remove the int. You know why we remove the int, right? Because we cannot
because it's already
defined. Yes. Okay, I think it works now. Okay, good. So yeah, let's go to the contact class, please. So what was difficult? Yeah, I was telling you that you are able to actually copy, but never mind. You continue it, doing it here. So name, and so where is name? There is no name here. Okay, and who is who? Who refers to relationship?
yes.
Okay. So this who put it relation, please. We will need it later as a relation. So okay. So if you test like that, what could be the issue? What could be the issue?
Oh, because non-static variables that can't be referenced from a static content.
Yeah, you have to use the word static here. Yeah. Okay. So it runs without errors?
Yes.
Okay. So okay, the first thing that we would like to actually do is that we do some printing. So we like to print. We would like to print. So we need to make a method, print contacts. Okay. And this method print contacts should take the contact array, my contacts, and print it out. So how it should print it out, let me send you slide that actually describe. So this is the first thing that we would like to actually have. Okay, let me see here. Would you like to see how the actually the print context looks like? Let me see here. I mean the signature of. This is a signature.
How do you do like line breaks when printing?
You can use /t. We have to close and open again.